Good morning. This week we have several things on our calendar. Make sure that if you have not completed the unit exam from last week that you do so as soon as possible. We are down to the last 2 weeks. I did send out an email regarding the end of the semester, and it affects some of you, so please make sure you're getting on your email and looking at that. Today's lesson is on rational functions. So the first thing that you have to be able to do is define the domain of a rational function. So remember that domain is all possible x values. What x values can you put into a function? So if you're looking here, we have the function f of x equals 5 over x minus 5. So the only value that we cannot plug in is 5, because if we plug in 5, we get 0 in the denominator. So our domain would be everything except 5. So we can write that in interval notation as negative infinity to 5 or 5 to infinity. Or you can say all values except 5. Discuss the behavior of f near any excluded values. So we have to think of what happens as x gets closer and closer to 5. So we would say this as x goes to 5, and then we'll put a little negative sign. So what that means is x gets closer to 5 from the negative side when it's below 5. So if you think of that, that's like plugging in numbers like 4.9 or 4.99. It's getting really close. So if you think about plugging in 4.9 in the bottom, we would get negative 0.1. Now, as that number gets closer to 5, that denominator is still going to be negative, but it's going to get really, really small. So we're going to take 5 and we're dividing by an extremely small number, which would mean that our function is actually going towards negative infinity. So we say our function's going towards negative infinity as x goes to 5 from the negative side. So then we have to look as x goes to 5 from the positive side. What's happening to my function? Well, that's like plugging in numbers that are just a little bit bigger than 5. So let's think of 5.1. Well, again, these numbers are going to be very small, but this time they're going to be positive. So we're taking 5 divided by a very, very tiny number. Now it's going to be positive this time, so we're going to say it's going to go to positive infinity. The next thing, again, we have another one that's talking about domain. Sometimes it is necessary to factor. So we'd have x plus 1, x minus 1. Okay, so your domain would be all real numbers except x equals plus or minus 1. If you're doing that in interval notation, you would do negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Discuss the end behavior near those values. So this time you're going to have to do it twice. You're going to say as x goes to negative 1 from the negative side, as x goes to negative 1 from the positive side, as x goes to 1 from the negative side, and x goes to 1 from the positive side. So if we're plugging in numbers close to negative 1 that are a little bit smaller than that, so it'd be like negative 1.1. So when you square that, it's going to be a little bigger than 1. So you're going to have a positive number in the bottom, a positive number in the top, but the top is going to be 2 over a really, really small number. So we would say f of x is going to positive infinity. Okay. Another way to double check this is if we looked at our graphing calculator. So if you plug this into Desmos or into your graphing calculator, so you'd plug in 2x squared divided by x squared minus 1. And a lot of times this helps people visualize what you should have here. So you can see as you're going from the negative side that you're going to positive infinity. As you're going close to negative 1 from the positive side, then your function is actually going towards negative infinity. So your y value is getting really, really small. On the next part, as x gets close to 1 from the positive side, very similar, or sorry, from the negative side, similar to what we did when we had -1 from the negative side. So that one's going to positive infinity. And if you look on the graph, that should match that as well. And if you have numbers just a little bigger than 1, very similar, because we're squaring it as going from the positive side of -1, and we are going to negative infinity. So you have several questions like that on your homework. The next part is talking about asymptotes. So you have to know how to find vertical and horizontal asymptotes. A vertical asymptote occurs when the function's undefined. And really with a vertical asymptote, that's when your denominator is equal to 0. The other type of asymptote we have to be able to do is our horizontal asymptotes. And there are 3 rules for horizontal asymptotes. 1, if the degrees are equal. If they're equal, then it is the ratio of the leading coefficients. For example, if I have y equals 3x plus 4 over 2x minus 5. The degree on the top and the bottom are both 1. So your horizontal asymptote for that would be y equals 3 over 2. 3 is your leading coefficient in the numerator. 2 is the leading coefficient in the denominator. If the degree in the denominator is higher than the degree in the numerator, then your asymptote is always y equals 0. The last one, if your degree in the denominator is less than the degree in the numerator, there is no horizontal asymptote. So the next problems that you have are finding the vertical and horizontal asymptotes. Remember, to find your vertical asymptote, it's where that denominator is equal to 0. So set your denominator equal to 0, solve that, and we get x equals 2. When you're writing the equations, it has to be an actual equation. You have to say x equals 2. You cannot just say the vertical asymptote is at 2. Your horizontal asymptote in this case, the degree on the top is 1, the degree on the bottom is 1. Again, it is the ratio of the leading coefficients. So we'd have y equals a -1. This next example, if your degree on the top is higher than the degree on the bottom, there is no horizontal asymptote. Your vertical asymptote, again, where is your denominator equal to 0? We'd have x squared equals 4, so x equals plus or minus 2. So x equals 2 and x equals a -2. If you have any questions, please make sure you contact me, send me an email, send me a text. I'd be happy to talk to you. Have a great day.